Are you tired of clicking on web pages one at a time and having to read them with your eyeballs? I was, until I discovered web scrapers. I built my first web scraper in order to create a database of drink recipes. Quickly, my love of potent potables was eclipsed by love of powerful programs. Soon I was web scraping full-time, building bots that pretended to be human, figuring out how websites were put together so I could break them apart, even writing scripts to be captures. It was so exciting being able to use all these different disciplines of programming and computer science and funnel them often in creative ways into web scraping. I've distilled some of the more powerful and fundamental techniques of web scraping into easy examples using Python's popular scrapI library. So whether you're doing app testing, research, data science, or just want a database of exotic drinks like I did, let's get scraping. So, this is not a Python course. It's a web scraping course that happens to use Python, but it does teach web scraping. So you should be familiar with the tools of the trade beforehand. You don't need to be a Python expert. I'm not sure if I'm a Python expert sometimes, but you should be familiar with Python syntax and programming concepts involving functions, so defining functions, arguments, calling functions, the usual classes, so that's classes, objects, methods, defining new classes and using objects in Python. We do a lot of extending classes in almost every section and overriding the parent methods in a couple of sections, and other Pythonic things. So list comprehensions, dictionaries, I love list comprehensions, really one of the best parts of Python, you should love them too. Nice to have regular expressions. So we do use them in a couple of cases, but feel free to learn them after the class too. You should also have some familiarity with the web. I'm going to put that in quotes. It's a little more nebulous, but listen, it's hard to automate something you don't know anything about, right? So HTML, you should know what HTML is. Know the parts of XML, tags, attributes, values, you know about IDs and classes in HTML. You should know the parts of my bad addresses, domains, paths, some notion of query parameters in HTTP. How a browser fetches files and loads web pages. So we're actually going to be discussing this one quite a bit and teaching it, understanding it as a huge part of web scraping. But if you're sitting there going, wait, what pages are made out of files? Like you may want to hit the books a little bit and then circle back. Other than that, well, web scraping is a multidisciplinary field. We're going to be touching on a lot of things, learning a lot of things, you don't have to know or understand all of them right now. Whatever other skills you bring to the table, I'm sure you'll be fine. So what is web scraping? Let's start this off by going over some web scraping terms. You may have heard web scraping being called many things. Screen scraping and web harvesting are what I think of as older terms for web scraping, a little bit out of date. Web crawling or web spiders or spidering all refer to moving from one web page to another via links. So, you can scrape data from a single page, or you can crawl across multiple pages, scraping data from each one. Of course, sometimes all these terms are used interchangeably, but in this course, we'll use the term scraping for getting data off of a single page, and crawling specifically refers to the act of moving from page to page. But we'll get more into those details in the second chapter. So bots or web bots refer more to automated interaction with websites or web apps, so this interaction may be with the goal of scraping data or with the goal of crawling from page to page, but it's the bot that performs this interaction. And the concept of interaction or automation of a web app is something that we'll explore more in Chapter 3. So you may be familiar with the traditional definition of web scraping that goes something like an automated program that requests an HTML web page or DOM meant for humans and then parses the displayed data. So I find this definition to be a little bit limiting. Not all data is HTML, right? Browsers are useful tools, and their DOM can be a great interpretation of this web data that sometimes we don't really need or care about it. Is all data meant for humans? Sometimes it is, sometimes it isn't. Sometimes it's somewhere in between, right? Let's look at a definition of web scraping that I like to use: a program that requests and parses any data on the web, especially in an unexpected way. So this doesn't necessarily have to be automated. Of course, many web scrapers are. This could be any data, text files, videos, could be HTML. I think the essence of web scraping, when most people talk about it, is this sort of unexpected or almost hacker-like use of the data. Maybe this data was even meant to be parsed by a computer program, just not your computer program. So web scraping is a lot of data detective work, really getting down and dirty, and understanding what's going on behind the scenes in order to repurpose the application for your own uses. Some uses of web scraping might be a crawler that scans medical patient boards looking for experiences with drug combinations, so lots of big data collection, natural language processing classification. You could have automated UI testing of a company's web app. Here, obviously you have permission of the people who own the app, but the app's code wasn't designed to be interacted with by a bot. So you're not scraping the data and parsing it in a traditional sense, but you're putting the data into a database. You are logging test failures and successes, and that's a type of data. You can have a bot that interacts with an airline flight search app, monitoring price changes. So here, there's a similar app interaction. It's logging data that gets uncovered at the end of that interaction. You probably don't have the permission of the airline company. But what if you're collecting that exact same data, only this time, your bot just makes requests to the airline's public API? Is requesting JSON data from a URL somehow fundamentally different than requesting a web application page meant for humans? And the thing is, there's no real answer to that question. The definition of web scraping is totally arbitrary. It's this kind of nebulous field that encompasses many skills and practices, so application security, networking, data science, natural language processing, law, data architecture. The bad news, this course will not teach all of these fields. But what I do want to teach is the sense of how to look at a web scraping problem and break it down correctly. You want to figure out the first step and the second, and if you do need to bring in outside help, say from a data scientist, you have a neat, nice contained little problem for them that slots in well with the rest of your web scraping project. And I do want to leave you with this sort of probably apocryphal quote, from Michelangelo about how he sculpted the statue of David. It's easy. You just chip away the stone that doesn't look like David. So really what web scraping is being able to look at a website, a huge collection of links and media and ads and garbage, and cut through all of that and see only your database. You want to chip away everything that isn't your data. And the first step to doing that, of course, is learning how the internet works how the internet works. So this is going to be a very brief summary, don't worry. So it's difficult to learn to drive a car if you've never experienced the concept of roads before. Right? Similarly, it's difficult to learn to scrape the web if you don't have at least a basic understanding of how the internet works. There are lots and lots of things that can go wrong with web scrapers. And these things are influenced by the different layers of the internet that we're going to be talking about. For example, if you made a programming mistake, the web server might say, "Hey, that request doesn't make any sense to me," or your own client may not know how to direct the request, or maybe your computer's Ethernet was unplugged. So that's going to look like a very different error, right? Maybe your router can't reach the web server, or maybe the other web server is blocking your IP address. This can be very difficult to distinguish from other types of server errors. Maybe the other programmer made an error, and there's a programming error on the web server. But being able to quickly and efficiently diagnose problems depends almost entirely on having a solid mental model of the internet and how it works. So the mechanics of the internet worked because of a series of layers of addresses and information. This is similar to postal addresses. So when you send a letter, the post office is going to do a broad sorting by zip code, city, and state, right? The post office only looks at the last line, and then they send it off to another regional post office. Then you have that regional post office look at the street address for delivery. Then, it might get to that street address, and an apartment manager will put it in the right mailbox based on the apartment number. Finally, maybe my husband picks up the mail that day. He sees that it's a letter from me, Ryan Mitchell, and physically hands it to me, like a router sending data to my local printer, right? I opened the letter and read it. There's a greeting inside with my name, a closing with the sender's name, and some content in the middle. Now, the whole point was to get me this content, but there are all these layers of addressing and envelopes, you have stamps involved. And so let's look at how this works on the internet. You have the physical layer. This is literally electrons on a wire. So high and low voltage is representing ones and zeros. This might be the ink on the envelope, in our letter example. Then you have the data link layer. This is the information that gets the data from your computer to the router. This is the layer with data frames and MAC addresses and that sort of thing. So, physical machines on the local network. Then you have the networking layer, or the network layer. This connects routers together. This is also the first layer where we get variable length, discrete packets, and IP addresses. So if you can talk to your local printer, but not reach the internet, that's the network layer problem. Then, we have the transport layer. This provides connection-oriented communication between hosts. So before, communication was all one-off discrete packets. Now, you have the concept of a flow of communication, or checking and handling and whether or not communication has been disrupted. So this is where you find the TCP and UDP protocols. You also find ports that doesn't need specific applications on your computer, that the data will get handed to. Then, you have layer 5, the session layers. So this builds on top of the transport layer to open, close, and manage the sessions, the connection sessions between applications. So if you've used AppleTalk or SCP, this is all in the session layer. Then there's the presentation layer. So this has string encoding, encryption, decryption, object serialization, files, what type of files, compression. And then, what we're going to be doing is spending most of our time in the application layer. So this is where you find HTTP, POST and GET requests, APIs. These all primarily concern themselves with the application layer. So what are the big takeaways from this at the end of the day? How should we think about the internet? Remember that each request you send has to go through many layers of wrapping and unwrapping and addressing and delivery to get to its destination and back. But at no point is a web browser required for this, right? Good news for web scrapers. A web browser is just a piece of software that sends requests and interprets responses. And we can do all of that ourselves with Python. Requests can be examined and replicated. Anything a browser can do, you can also do with a web scraper. I mean, by definition. So get comfortable with the internet, ditch your web browsers. I mean, unless you're watching this video on a web browser, obviously, and head over to the next section where we actually build our first web scraper. Enough talk about web scraping theory. Let's build our first actual scraper. So you should already have pip installed, which is the Python package installer. If you don't, go get it, review the Python package management, and then come back to this video. But pip makes it really easy to install scrapy with a one-liner. So pip install scrapy with a capital S. If you run into issues, check out the scrapy installation guide, but after this is installed, you should have access to all the command line tools. So try scrapy, help, just to make sure everything looks good. Alright, so now we want to scrape a web page with scrapy. So here's the page we're going to scrape, pythonscraping.com/linkedin/iatf.html. Nothing too fancy, I replicated a very famous IATF, that is, the Internet Engineering Task Force, paper, added some tags, cleaned it up a little bit, just so we can sort of use it as target practice for web scraping. And back to the terminal. The first real scrapy command we're going to want to execute is start project. So scrappy start project yatf_scraper. This will create a template for IATF scraper project. Scrapy creates a lot of different stub files that are somewhat optional. You don't need to fill all of them out in order to start scraping, but we will be discussing these files in the upcoming videos. Just as a quick overview, scrapy.cfg holds configuration information. Items.py defines the objects or the entities that we're scraping. Middleware contains various scrapy hooks. Pipelines.py define functions that create and filter items. Settings.py contains project settings. Then finally, the spiders directory. So this is what we're going to focus on right now. It's really sort of the powerhouse of your ScrapeI project. In fact, a ScrapeI project can be thought of as primarily a collection of spiders, but we need to let ScrapeI know about each new spider we want to make with the new command. So let's navigate to our spiders directory. cdietf spiders. Alright. And tell it to make the new spider to go to the domain pythonscraping.com with ScrapeI genspider yatf, the name of the scraper, pythonscraping.com. And you can see it creates this sort of template spider file here. The first thing we want to do is modify the start URL. That's going to be linkediniatf.html. There's also this parse function here that is passed a response object via ScrapeI, and we want to fill this in with something that will return an object containing the data scraped from our site. Essentially, this turns the response object into a parsed Python dictionary of data. So we have this response subject to work with, and if you look at the page source, you'll see that this title is demarcated by this span class equals title tag. And there are two main ways to capture this title string with ScrapeI, using XPath or using CSS. So if we want to use CSS, all we have to do is title response.css span title, and we use the text pseudo selector and .get as a ScrapeI function that gets the first tag retrieved that matches the CSS. If we wanted to get a list of tags, we'd use getAll. And then, doing the same thing but with spath, span class equals title/text, and then that same .get. Alright. So now both of these methods will work just fine, but during this video series, we'll be using the XPath selectors. So let's stick with the second line using XPath, and I'll just comment that out. What we want to do is return a Python dictionary containing this title data. And there, that should be it. We can run the spider using ScrapeI function, runSpider.iatf.py. And you're going to see a lot of output here, but if we search for avian, there you go, our spider works. In the last video, we very quickly touched on how to work with the ScrapeI response objects in a function and extract the data that we want from them. So remember, there are two main ways to do this, CSS selectors and XPath selectors. Although CSS notation may be tempting to use at first, especially if you have a lot of experience with front-end web development and are very used to using CSS, I would caution against it. CSS selectors are far less powerful than XPath. Although some pseudo-classes have been added to work around some of the limitations, you'll likely run into long-term problems if you stick with CSS and completely ignore XPath. So we'll also be using XPath throughout these videos. The XPath syntax can seem a little convoluted at first, but it's actually extremely flexible and powerful, and you can do just about anything with it. It's like the regular expressions for XML or HTML. So let's take a look at a few examples. If you want to navigate to a particular tag in XPath, you have a couple of options. You can do /mulbaudative1, and this will navigate to, say, a title on a web page. But it's really annoying. You have to go from the top tag, passing through every intermediate tag to get to your H1. What if you want to go straight to the H1 tag without passing through every tag along the way? Just do //H1. The double slash allows you to select tags anywhere in the page, without starting from the top level of the tree hierarchy of HTML. You can also do something like this, and this will select only the H1 tags that are immediate children of the div tag. You can also do div H1. In contrast, this would select an H1 tag that falls anywhere under a div tag, regardless of whether or not it was an immediate child. And as seen in the example from the last video, elements are selected by attribute using this @symbol, @class equals title. Let's bring this over into our examples. This will select any span tags that have the class title or the attribute the span tag is equal to the string title. You can also select the text from the attribute of the tags themselves. So if we wanted to select the ID attribute, we do @ID, and this will select the value of the ID attribute where the class attribute is title. Of course, you don't usually want the attribute text or the attribute value. What you want is the inner text from the tags. And as seen in the last video, you're going to be using the XPath tag selector a lot. So that's just /text and that's it. About 99% of the XPath selectors you will ever want to write in web scraping will follow one of these patterns. So as a challenge, go back to the page we scraped the title from in the last video. pythonscraping.com/linkedin/iatf.html. So create a ScrapeI project with a spider that scrapes, not just the title as in the last video, but all of the important content from the page in an organized way. So you might want to look at the author's name, the date, the subtitles, the text, etc. Look around as well. There may be multiple ways to retrieve the same information. After you have a solution you like, check out the next video and we'll compare notes. That I hope you enjoyed scraping your first web page. A huge skill in web scraping is just being able to stare at a page as HTML and not get lost. So if you manage this, you're halfway there. Some other skills you may have used: digging to find the cleaner sources of data, being a little creative, not being afraid to get dirty and do some data wrangling, looking for perhaps hidden data, if you saw any of that. So, the fields I ended up collecting, although you may have gotten more or fewer of them. The RFC number. This might be useful if you're collecting a database of these things. I had the title, obviously. The date, the description, the author's name, the author's company, the text of the document and the list of titles and headings. If you've got the description field, congratulations. If you didn't, did you happen to notice the data in the header of the page? Page headers are often extremely valuable sources of data. They have metadata meant for search indexers like Google, other web crawlers. Remember, to get the text content of the tag, you use text in your XPath. To get the value of an attribute in the tag, you use the @ with the name of the attribute you want. So when we're getting the description, you're going to use @content to get the value of the content attribute of the description tag. Sometimes the data and the metadata will be formatted better or at least differently. So you should check it out if you want options. For example, in the visible text of the document, you have a date formatted with the day. In the metadata, you have just the month and the year. Of course, you may want more information rather than less and say you prefer the date with the day field in it. But it is formatted differently, so you do have options. This is also true with the author and the title, where I have some alternative ways of getting the data shown here in the comments. Also, it looks like we have some internal codes on this page. Here, we have the version. Here there's another case where we have the RFC number. If we were scraping a product page, we might find things like the UPC, the Universal Product Code, in the metadata here. You might want to save unique identifiers like this. They may come in handy later for, say, keeping things organized in a database or referencing it on the sources of website later on. So anyway, this is just my solution. It's not the solution. So I'd encourage you to run it, play around. Maybe you can do better. So in this chapter, we're going to switch gears a bit and focus on creating web crawlers that collect data from Wikipedia. Now, before you get any bright ideas, it is completely useless thing to build web crawlers for Wikipedia in real life. If you want data for Wikipedia, they have fantastic APIs you can use, right? So scraping them is really just a waste of your time and their servers. However, they do have a lot of links and articles and things. You can click on one link to the next. Their HTML is really stable. It doesn't change very often. And for this reason, it's a really great site to use when you're learning web crawling or when you're teaching web crawling. So if you do feel inclined and you do want to crawl them as practice, I would highly encourage you to chip in towards the cost of their servers. I give them $20 every now and then, and they are a really great organization. Anyway, let's start a new web crawler. We're going to call this one Article Scraper rather than naming it Wikipedia Scraper, because the type of the thing we want to scrape is an article. So ScrapeI start project article_scraper. Alright. So we can name the individual spiders after the sites they scrape for the articles, but the project itself is going to be called Article Scraper. Oops, sorry about that. We definitely want to do start project and not star project. Alright. So then we navigate to the Article Scraper directory and to the spiders directory, and then let's make our Wikipedia spiders. So scrapey genspider Wikipedia, en.wikipedia.org is going to be our domain, and that's the English language domain. Right, so let's check it out, see what we have. Spiders, Wikipedia. Great. So the first thing we want to do is extend scrapey's crawl spider class instead of scrapey.spider. And we need to make sure we import this. So from scrapey.spiders, import crawl spider. And the other thing we're going to import is rule, which we'll get into in a second. And we also want to import link extractor. So from scrapey.linkextractors, import link extractor. And rules, link extractors, and crawl spiders work really well together, as we're going to see. Needs to be https en.wikipedia.org, and let's actually make our start URL /wiki/Kevin_Bacon. You may have heard of Kevin Bacon the actor, also of course the namesake of the game 6 Degrees of Kevin Bacon. So let's fill in a few things that we want to collect from each page in the parse function. Let's get the title response.spath. That's going to be h1/text.get, or response is path, h1/i/text.get. So for works of literature or movies or things like that, they're actually italicized. So we want to have the italicized version in there as well if we don't find the first version. Then we have the URL. That's just going to be response.url, pretty straightforward. And the last edited, this is the last edited date, at the bottom of Wikipedia pages. This page was last edited on the 27th of October 2020. There's the timestamp there. We want to grab that too. So the last edited date is going to be a response.xpatly, where the ID is footerinfo lastmod, get the inner text.get. Okay, great. So now we have something that looks just like the scraper we wrote in the last chapter, but what makes it a crawler and not just a scraper? We need to give it rules for the links to follow. So we can do this by using a scrapey rule object imported at the top, and that takes as its arguments a scrapey link extractor object. So the first target is going to be a scrapey link extractor. The callback is going to be, let's call this the function parse_info, and then just change this name. I like to use parse_info for crawl spiders and parse for regular spiders. And then we want it to follow links. So follow equals true. This just means that every time it finds an internal URL it follows that, then it keeps following and finding new internal URLs and just basically goes ad infinitum. So let's take a look at that first link extractor object. This is the thing that actually parses the HTML page and finds new Wikipedia links to visit. This takes in an allow argument. I actually have it in my clipboard right here. So unfortunately, regular expressions is outside the scope of this class, but what this regular expression means is that we want pages at /wiki and then /some text, sort of like this Kevin Bacon URL. And we do want to exclude any URLs that contain colons in them. So if you look at Wikipedia, pages that contain colons in the URL are things like the special pages, the discussion pages, talk pages, the random article page, right? So what we want are just those URL that look like /wiki /some text. And now we can run this spider using the usual commands. So scrapey run spider wikipedia.py. Alright, great. And you can see what it's doing is it keeps crawling to new Wikipedia pages, and the only way it'll stop, unless Wikipedia runs out of pages, which is probably unlikely, is with a Ctrl+C. And this is multi-threaded, so you may have to press it a couple of times, but there you go. Your first Wikipedia crawler.